you doing? It's MrDoTheMath here, and today we're going to talk about solving right triangles. All right, solving right triangles basically implies this: when you're trying to solve a right triangle, when they say solve, you have to find all the sides, and all the angles. So when they say solve the right triangle, you got to find everything. They want everything. Okay. And so we're going to be using our trig identities to find everything. And so essentially, when we first started off and we were trying to find, say, if we knew that this angle was 45, well, no, we're going to say 40 degrees, right? If we knew this was 40 degrees and we had this was 5 and this was x, in order to find the measure of x, what would you use? What's the trig identity we would use? Yes.
When you do
So in relation to 40, what is 5?
Tangent.
You would use tangent, right? So you would use tangent 40, right?
Yeah.
Equals opposite over adjacent, right? All of this came from our SOHCAHTOA. Yes? Y'all remember that? So we had the adjacent side to 40 and the opposite side to 40. Alright? That's where we get the T, the OA from. Right? Tangent. Right? Now, what we're going to do now is we're going to figure out what these angles are. So if there is no angle measure, and say for instance, so we'll disregard that, and we're trying to figure out what angle. If we label this A, B, C, right? If we label this A, B, C, and give me a hypotenuse length.
25.
All right, let's do 25. All right, we said 25, and they said we need to find the measure of angle C, right? In order to find the measure of angle C, what would be the trig identity associated with this C, based on what we have? We have a 5 and 25. Huh? Very good. We'll have the adjacent side and the hypotenuse. So we'll use cosine. So essentially we have cosine C equals adjacent over hypotenuse, right? Everybody good so far? Yeah. Okay. Now, since we know what these numbers are, we would just be solving for C, right? And so the math associated with this would be, how would we get C by itself? All right? To get C by itself, we would essentially have to divide both sides by cosine, right? When you divide both sides by cosine, you have basically 1 over cosine here, right? So the cosines cancel and you get C equals 1 over cosine 5 over 25, right? 1 over cosine is the same as writing inverse cosine. Cosine to the negative 1 power. And so, depending on the calculator that you have, we can find that button. All right. So, if you have a TI-30, it is the inverse cosine button is going to be above the cosine button. If you have a TI Inspire, your big calculator, Ty, toss me a calculator, please, sir. Toss it. If you have this TI Inspire, you would hit the trig button, and inverse cosine would be underneath cosine. All right, here you go, Ty.
What about mine?
If you have yours, you would still have to use. So in order to, it's much like this one. You would have to hit either the second button or the shift button, or that green, the extra color button. So like all these buttons are like pretty much the same color. The only button that's not the same, right? You'll hit that button, and then you will hit your cosine, right? Because of yours, what you would do is you'll put in 1/5 or 5 over 25 first, and then you will hit inverse cosine. Okay? So let us work it out. So if we have, for this particular problem, 1 over 5 over 25. So to solve for the measure of angle C, we'll have the inverse cosine of 5 over 25, which is the same as 1/5. What do you get in your calculator? All right, anybody else? 78.4? 5. Thought you said 4. 78.5. Okay. Everybody get that? Give me a thumbs up. Let me know you got that. No? All right. So with your calculators, you're going to end up pushing like the second button or the shift button, and then you're going to hit the cosine button because cosine has inverse cosine above it, right? And then you'll put in your ratio, your fraction. All right, here's the other thing you must not do. Do not write it as a fraction. Use division. So it's 5 divided by 25. Push the division button. Do not push the fraction button. Don't make it a fraction. Okay? Use what? Okay, well yours allows you to do that, but typically you need to use the division. Okay? We good? Okay, cool. Let's try another one. Alright? Now, what if I have a... We should have left this here. Alright, let's do another one. So, we got this triangle here. Right? We're going to label it A, B, C. Right? And this is a right triangle, and this is 20, and this is 15, I believe. Right. Find the measure of angle... Let's find the measure of angle C. Alright? Find the measure of angle C. What would be the ratio? Alright, based on C, what's our trig identity? What would TOA, very good. Tangent, right? We have, based on C, we have the adjacent side to C, and we have the opposite side to C. So, it would be tangent C equals, what's that? Opposite over adjacent, right? C.
Oh, C's over there.
Yeah, C's right here. That's an A. C is here, right? Adjacent, right? Adjacent is 15. Opposite is 20, right? So we have our ratio. To solve for this angle, though, we got to get C by itself. So we would do inverse tan. Inverse tan, 20 over 15, would give us the measure of angle C, right? So when you put that in your calculator, what do we get? How many students got 53? 53 point what? 53.1 degrees?
Yeah.
Yes? Cool. Yeah. Now, if I say solve, so cool. We got this 53.1. Alright? You get that. So whenever you're trying to find an angle of a right triangle, you use inverse, sine, cosine, and tangent. Right? Let's look at an example. Let's solve a triangle, right? Let's solve a triangle, because that's what we're supposed to be doing today, right? We're gonna solve a triangle. Alright? So we got this lighthouse situation. I won't draw the lighthouse, but we're just gonna say this is A, this is B, this is C. This is 42 degrees, right? That's 42 degrees. This is 70. The lighthouse is 70 feet tall, right? So now we need to find everything else. Solve this triangle. Solve the triangle. Okay? So the first thing we may want to do is we might want to you want to find all the outside or the inside first. It's up to you. What do you want to do? You want to do the inside first? Inside came out faster. Alright? So if you do the inside first, you just use your simple like beginner geometry skills, right? The measure of the inside of the angles of a triangle is how many degrees? 180 degrees. So we know this is 42 and this is 90, right?
90.
This is 42 and 90, so it's 90 plus 42 minus
132 minus
48. You get 48 degrees. So that's the measure of C. Everybody good with that?
Yeah.
That all came from 180 minus 42 plus 90. We all good with it. That gave us that. So we solved everything inside the triangle. Everybody good? We Gucci? Alright, now let's find BC and let's find AC. Alright? If you want to find, let's find BC first. So what would you do to find BC?
When you do
Let's use 42. So
no.
So if this is X, we make this X and this Y. So to find X, so 70 and X gives you what trig identity? Tangent, right? So based on 42, this will be the adjacent side. This is the opposite side. So you get tangent 42 equals what? Opposite over adjacent. We good so far? Right? So opposite over adjacent. So we get 70 times tan 42. 70 times tan 42 gives us x. Right? 63.02. Alright, 63.02. Alright? So that is x. 63.02. Right? And then so to find y in relation to this.
We can do
What trig identity would that be?
wouldn't that be
That's adjacent
so
and hypotenuse.
cos.
Chi, right? Cosine. Cosine 42 equals adjacent over hypotenuse. Okay? And now, whereas, Ty, you with me? The x was at the top here, the variable was at the bottom here. And I told you guys, these switch places. So y would equal 70 over cosine 42. Alright, so remember, anytime that the x is at the bottom, it switches with the trig identity. And anytime the x is at the top, you just multiply into that trig identity. So now you got 70 divided by cosine 42, Micah. Alright, 70 divided by cosine 42 is what? 94.2, right? So, we've solved for the triangle. So we got all of the sides, and we have all the angles, right? And we know that's 90, right? So that's solving the triangle, right? So you use your trig identities to figure out what's missing, right? Yes, Cam? This cosine one? Okay. Yeah, sure. So basically, we set up our ratio, right? Cosine of 42 adjacent over hypotenuse is this going to be 7 over the hypotenuse, which was the unknown. All right. To solve for y, we had to multiply both sides by y and divide by cosine. So what I said is simply the simple algebra is that the cosine and the trig and the variable switch places. So you get y in place of cosine 42 and cosine 42 in place of y. And so you'll just enter this into your calculator. So it'll be 70 divided by cosine 42. And depending on your calculator, you might have to put 42 in first and then push cosine. Right?
Thank you.
Alright. We good? Yeah? Alright, let's look at one more example. Right? So this is a word problem. It's a word problem. Let's erase this part. Alright, I'm going to read the situation and then we're going to draw it. Alright, it says, we're in a theater. Suppose your school is building a rake stage. Alright, there's something like this. It's building a rake stage. Right? The stage will be 30 feet long from front to back. 30 feet long from front to back. This is the stage. Right? It's 30 feet long from front to back. Right? The total rise is 2 feet. Right? A rake, this is an angle of elevation, is 5 degrees or less. 5 degrees or less is generally preferred for the safety and the comfort of the actors. Is this rake safe? All right, so basically it's saying a rake stage is a stage that has a slight grade in it, right? And we're going to see if this is going to be it. So what they want to know is, we want to know what this measure is, right? So based on the information that we've provided, we said that the stage is 2 feet high and it's 30 feet long, right? What would be the trig identity to help us find this angle here?
Wouldn't it be so
Good. Sine. So you'd be sine of, we'll just say theta for now, equals opposite over adjacent. Hypotenuse. Opposite over hypotenuse. Okay? So since we're trying to find this angle though, we'll have the measure of angle theta equals the inverse sine 2 over 30. Okay? What is the answer? Yes, ma'am.
3.8.
Everybody get 3.8 degrees? 3.8 degrees. Right? Now, remember it said it had to be less than 5 degrees? And so Yes, this is safe. Right? That's safe. Okay? So to recap everything that we've done so far, it happened really fast. To solve a right triangle, you have to find all the sides and all the angles. Right? And when we're trying to find the angles of a right triangle, knowing this is a right triangle, you use the inverse of every trig identity. So in this case, this was the opposite over here, this is the hypotenuse. You would use the inverse sine to find the measure of the angle. So you use inverse sine, cosine, or tangent to find the measure of angles. You use sine, cosine, or tangent to find the lengths of sides. Okay? That's pretty much it. Alright? So, any questions? Yes, ma'am.
It's about my calculator.
It's about your calculator?
About this.
About this? Ask, what's the question?
Okay, so I put in like, sine, whatever, and then I put in 2 divided by 30, and it gives me like not.
A different number?
Yeah.
So your calculator might be set in radians and not degrees. We'll check that out. Okay, so if you have a TI Inspire, make sure that your setting is in degrees and not radians. Yes, ma'am?
So I'm not really understanding like the -1 thing. What's it called? The inverse?
Inverse, right. Because
I don't really know when to do it.
you use inverse when you're trying to find angles.
I'm trying to find angles.
When you're trying to find angles. And so inverse is basically sine over 1, right? Anything over 1 is the inverse, right? Just like, remember when we had like x to the 3rd power, if we put it in the bottom, it would be 1 over x to the -3. Everything changes, right?
Yeah.
All right, so that's all that was. Okay. Good. All right, so if you have any more questions, comment below. All right, don't forget to like and subscribe. MrDoTheMath out.